Hello everyone. Today we're gonna go over the definite integral. This is chapter 5.2 in the Calculus Volume 1 OpenStax textbook. Okay, so we're gonna read over the definition. If f of x is a function defined on an interval, the closed interval a to b, the definite integral of f from a to b is given by the integral from a to b, f of x dx is equal to the limit as n is approaching infinity for the summation of I equals 1 to n f of x index times the change of x. Provided that the limit exists, if this limit exists, the function f of x is said to be integrable on the closed interval a to b, or is an integrable function. Okay, so again, going back to the indefinite integral, the indefinite integral is indefinite because it infinitely spans from negative infinity to infinity. Like, it doesn't matter how the function is set up, it goes towards infinity. So with this one, since it's defined on a closed interval, you're only finding the area between between these two bounds. So now we're gonna go ahead and take a look at the table to show what I mean. Here are the properties of the definite integral. They're similar to the indefinite integral, except that the c is basically gone now. So we're gonna go ahead and take a look at this. And then I'm gonna give you some problems that we're gonna go over together. Okay? So cool. Let's go ahead and go on here. Okay. I'm just gonna make some problems up. So we have the integral from 0 to 2 x squared dx. And we want to know what the area is between these 2 points. So there is a rule to this. Basically, if we're given the integral of f of let's say x dx between the bounds a and b, the integral is going to be f of a minus f of b. Okay, so if you recall, the integral of x squared is going to be x cubed over 3, and this is going to be set by the bounds from 0 to 2. So you following this equation here, it's going to be, sorry, I messed up. It's f of b a. Okay, so now it's going to be 2 cubed over 3 minus 0. Right? Okay. So what is 2 cubed? 2 cubed is 8 over 3. So therefore, the area, oh, where did it go? The area between 0 to 2 for the equation x squared dx, for the integral x squared dx between these bounds, is going to be this. Okay. Cool. Let's do another problem. The integral from 1 to 3 e to the 4x dx. Okay. If you recall, the integral of e to the x is going to be e to the x. So this is going to be e to the 4x 1 to 3. I'm just gonna double check my work. Sorry. My bad. I forgot the 4. Okay. Then if we were gonna plug this in and rewrite it, it'd be e to the 12 over 4 minus e to the 4 over 4. You could simplify this further with a calculator, but honestly, I don't think in college, at least in this like level of math, they're gonna let you use a calculator. Yeah. Okay. Let's do another problem. The integral from, let's do 1 over 2, 1 over x dx. This one's simple enough, right? Okay. Give me 1 second, please. Okay. So what is the integral of 1 over x? It's going to be ln x. Or technically ln absolute value x. From 1 to 2. And when you plug this in, it's going to be ln 2 minus ln 1. But the natural log of 1 is 1. So this just goes away. Actually, I think it's 0. Oh, ln 1 is 0. Okay, it goes to 0. That means that the answer is going to be ln 2. So when you're doing these problems, I would practice with the properties. Look at this table here. Sorry. I would do practice problems. In each chapter, they show the solution. And if not, then I'm sure that the answers, or at least like a similar problem, would be online. This one can be kind of difficult, especially if you don't know derivatives that well. I think in the next video, actually, I'll just explain it here. There's an average value of the function. So basically, if you wanted to find the average area, I guess, that's like basically in the whole general total of the function given, you can use this equation here. In the book that shows the proof, but honestly, I'm not going to go over that. Nobody has time for that. But anyways, yeah, I recommend these example problems. Like, if you don't feel very confident in them, I'd rely on these because they show the solution. And I think it's very helpful. And some of them even show you how to envision it. Like this one right here, it shows, actually, let's go up. Okay, in this problem, it's asking you to find the total area for the equation x minus 2 over the x-axis on the interval 0 to 6. So yeah, you could find the total area without drawing a graph, but I think it's very important to see the graph because as you can see, since it goes -2, there is an area that's below the x-axis, which means that the area is going to be negative. And you wouldn't really have known that if you didn't like draw it out or if you like didn't envision that. Yeah. So basically, because this equation was going below the x-axis, it would have calculated the area differently, which isn't really good. Then that you would get a wrong answer, right? Seeing the diagram would help you see that that there's an area that needs to be calculated and taken into account. For this problem here, I would draw it out and then I would solve the area in terms of a triangle. I mean, yes, we could find the area using the integral, but this is like finding it in terms of triangles because that's just the way that it was structured. You could actually find the area with using area of a triangle. Please note that like you can't use triangles for all the problems. This just it happened to be a slope, so you could use it. Okay, so that's all for today. Thanks for watching, guys. I'll see you guys in the next video.